Welcome to Making and Treating of Steels course, Lecture 30. Today I am going to speak about the mainly normalizing and hardening and tempering treatment process for eclectoid steel. Let me emphasize on normalizing treatment process. For hypoeclectoid steel, above A3 range of the temperature was chosen. For hypereclectoid steel, above ACM, cementite line, above ACM was the temperature chosen. Now, what is the mainly the process, the purpose of this particular normalizing treatment? Basic difference from the annealing process is the temperature ranges are quite same. For hypoeclectoid steel above A3, for hypereclectoid steels above ACM temperature was a temperature range, but the sample is cooled in air, whereas in the case of annealing process the sample was cooled, the material, steel material was cooled within the furnace in annealing process. And in annealing process the end product, microstructural product was coarse perlite, whereas in the case of normalizing process it is fine perlite. Fine perlite is formed, and that particular fine perlite has reasonably good hardness and ductility, whereas in the case of annealing process, as you have seen, hardness, good hardness was not achieved. Here by doing air cooling process which was achieved. For hypoeclectoid steel, mainly above plus 50 degrees temperature was chosen, which was done for the annealing for hypoeclectoid steel. Similarly, for the hypereclectoid steels, only ACM temperature. For example, for the annealing process it was A1 for hypereclectoid steels. For normalizing it is ACM temperature. For hypereclectoid steels normalizing, ACM temperature range was chosen, and the air cooling was faster cooling rate, and the formation of the cementite, the gap between the cementite, large spacing, time is not provided, so that is why it forms fine perlite in the case of normalizing treatment process. Now let me talk about hardening treatment process. For the eclectoid steel, for hypoeclectoid steel above A3, for hypereclectoid steel ACM, just like normalizing, the temperature chosen. But the basic difference from normalizing to hardening treatment, the cooling media is, in the case of this hardening treatment, the cooling or quenching media is water, which is more faster than the air. The critical cooling rate is achieved in the case of hardening process. That is basic difference. And how do you achieve? By choosing the water, it is basically, as I mentioned, cooling curves. This particular perlite start, perlite finish, that is time temperature transformation curves. This particular oil quench, normalizing, full annealing, water quenching is nothing but hardening process. This is, you are avoiding to touch this particular nose of the TTT curves. This cooling curve is avoiding touching of this particular TTT curve. This is cooling curve, CCT diagram, cooling curve, and this is TTT curve, and that is how you will get the martensite. Immediately by doing this particular process, quenching in water, you will be getting the product as martensite, which is hard and brittle phase. That is hardening treatment process. Now coming to this particular another treatment called tempering treatment. What is the aim of this particular tempering treatment? As you have seen, the hardening process, the structure in as quenched state, from the hardening treatment there is highly supersaturated martensite was formed, and there will be some amount of retained austenite, some undissolved fine carbides with the carbon. It could be the titanium carbide and niobium carbide, and from the cold working process there will be auto tempering which was happening. Auto tempering is nothing but below A1 temperature of A1 is ejectoid temperature. Below A1 temperature was chosen for the cold working process also. Within that particular process, you call it as auto tempering process was occurred, and rods and plates form of carbide particles was formed, and segregation of carbon was segregated here and there is no homogeneity. This was the problems from hardening process. How do you overcome these problems? That was the main aim to develop the tempering treatment. Then the objectives given by tempering process are relieving the internal stresses by retained arsenate which the internal stresses has formed, and restoring the ductility toughness which was lost from hardening process. You can restore by doing the tempering treatment. Usually you do after hardening tempering treatment, so that hardness and ductility, toughness, all the three properties you can improve if you do combination of the process. And to improve the dimensional stability, there will not be irregular dimensions, so you will do this particular process. And magnetic properties from the arsenate to the ferrite, for improving the magnetic properties you will do this particular tempering process. The tempering process, mainly the hardened steel was not suitable for the engineering application. That was the conclusion for hardened steel, and many of the reports are said. So then how do you made it suitable for the tempering process? The following three are the drawbacks why it is not suitable for the engineering application after hardening treatment. Because the martensite which was obtained was very hard and brittle. Because of this, there will be a crack formation in the engineering component when it is going for the direct application. The another thing is the formation of martensite from the arsenate, which also produce high internal stresses. So how do you avoid this particular internal stresses, and how do you improve the brittlity to decrease the brittle nature and increase the ductility? So that is these are the two problems. Another third problem is the structure obtained. It is combination of martensite and retained arsenate. These both the phases are not stable, it changes. So how do you make it dimensionally stable, and this avoiding these particular problems, how do you make it suitable for the engineering application? Then this particular tempering was introduced and reduces all these particular three problems. That is, the tempering is the process of heating the hardened steel to a temperature of maximum up to A1 and soaking for around 1 hour and cooling in the air. That is slow cooling. Slow cooling mainly you can achieve from the furnace only. Slow cooling was done in the furnace. That is tempering process. And by that, if you see the application, the hardness and toughness, the toughness was increased, and hardness, which was very hard, brittle nature, was decreased. So this was earlier from the hardening process, it is changed. And this is main point about this normalizing, hardening and tempering process. Now give your opinion on this particular statement. Aim of tempering treatment is to restore the ductility and toughness after quench hardened steel. Is it true or false?